The sun, our life-giving star, is a serene and constant presence in our sky, isn't it? We rely on it for warmth, light, and energy. But what if this celestial body turned against us, unleashing a solar storm so powerful it could plunge our world into chaos? What if the sun, instead of being our friend, became our worst enemy in 2025? In 1859, British astronomer Richard Carrington was observing the sun when he witnessed an extraordinary phenomenon, a sudden flash of bright light that lasted for about 5 minutes. This event, now known as the Carrington Event, turned out to be the most intense solar storm in recorded history. The sun ejected an enormous amount of hot plasma towards Earth, causing unprecedented destruction. Gold miners in the Rocky Mountains awoke at 1 a.m. thinking the sun had risen because the auroras were so brilliant. Telegraph systems worldwide operated without power, running solely on the massive current generated by the storm. Messages were transmitted from New York to Pittsburgh without any electricity. The awe-inspiring auroras were not the only remarkable aspects of this event. Telegraph operators received electric shocks, telegraph papers caught on fire, and entire systems became inoperable. In some instances, operators found they could disconnect their power supplies and still send messages, demonstrating the storm's intense electrical power. This level of disruption was astonishing, especially considering the relatively rudimentary electrical infrastructure of the time. Imagine the havoc such a storm could wreak on today's highly advanced and interconnected global electrical grid. What's even more alarming is that these events are not rare. Auroras, typically visible only in regions like Iceland or Finland, were seen globally during the Carrington Event. Even in Australia, the local newspaper described the sky's transformation into a stunning hue of red, lighting up the heavens in a spectacular display. The sheer scope of the auroral visibility underscores the immense power of the solar storm. In 2012, a solar superstorm nearly as powerful as the Carrington Event narrowly missed Earth by just 12 days. Solar activity occurs in cycles, with the sun's magnetic field flipping every 11 years, leading to increased solar activity. We are currently entering the next solar maximum, making the question even more pressing: what would happen if the Carrington Event occurred today? In our modern age, everything relies on electricity. Our homes, phones, and even many cars depend on it. A Carrington-level event could knock out the world's energy grid for years. The Carrington flare carried an energy equivalent to 700 billion Hiroshima bombs. A 2013 study estimated that such an event would cost the North American power industry alone around $2.6 trillion. Global blackouts would ensue, plunging the world into darkness. For the first time in centuries, the night sky would be free from light pollution, offering an unparalleled view of the stars. The blackout would occur because the event would damage extremely high-voltage transformers, which are incredibly difficult to replace. But what about our activities in space? Satellites, rockets, and telescopes would face significant threats. If a solar storm occurred while astronauts were on a moon base, the radiation would pose severe risks to their health. High-orbit satellites, crucial for communications and GPS, would be damaged by high-energy particles. Starlink has already lost $50 million worth of satellites to geomagnetic storms. Even more frightening is the fact that the Carrington Event, the largest solar storm in recorded history, is relatively small compared to older events. Scientists have examined tree rings and found spikes in carbon-14 atoms, indicating massive solar flares in years 774 and 994, potentially 10 to 100 times larger than the Carrington Event. The sun cycles, much like the seasons of Earth, cause these solar storms. Every 11 years, the sun's magnetic field flips, leading to increased solar activity. Our current cycle began in 2019 and will reach its peak in 2025. While we continue to learn more about these cycles, one thing is clear: we need to be prepared for 2025. So, how can we protect ourselves from such a catastrophic event? It all begins with detection, giving everyone as much warning as possible. Using the SOHO spacecraft, scientists constantly monitor the sun for signs of mass ejections. When one is detected heading towards Earth, calculations based on its speed typically provide 12 to 48 hours of warning. This time is crucial for taking necessary precautions. Governments would need to sound alarms and order energy grids to be shut down and disconnected. Everyone would need to unplug their electronics and wrap their small devices in tinfoil to prevent them from being fried. Satellites would be put into safety mode to protect them from damage. If these measures are taken swiftly, we could reconnect the grid and resume normal operations. However, hospitals and emergency services, which rely heavily on electricity, would face severe challenges. Without power, people would likely die. Many electronic components in cars, such as screens, charging ports, and reversing cameras, would be destroyed. While the overall risk isn't extremely high, the danger is real. Some scientists believe there's a 12% chance of a Carrington-level event occurring within the next decade. As we approach the solar maximum, the threat looms larger. If an asteroid were heading towards Earth, the world would be in a frenzy. But solar storms strike silently, posing a global threat. It's not a matter of if one hits us, but when. And when it does, we must be prepared. The potential damage of a solar superstorm extends beyond the immediate effects on electricity and communication. The disruption could cascade through various sectors, impacting our daily lives in unimaginable ways. Think about the food supply chain, relying on refrigeration and transportation systems. Without power, perishable goods would spoil, leading to food shortages and a potential crisis. Financial systems, dependent on electric transactions and data storage, would be thrown into disarray. Stock markets would crash, and economic instability would ripple across the globe. Banking systems already vulnerable to cyber attacks would face unprecedented challenges. Transportation networks, including air travel, rely on GPS for navigation. A compromised GPS system could lead to accidents, delays, and a halt in global travel. Communication, both personal and professional, would be severely affected, making it difficult to coordinate rescue efforts and maintain order. Medical facilities, from hospitals to pharmacies, would struggle to operate without power. Critical life support systems, refrigeration for medications, and electronic medical records would be compromised, endangering countless lives. The environmental impact could also be significant. Wastewater treatment plants relying on power to operate would fail, leading to water contamination and health hazards. The lack of power would also halt industrial operations, causing economic losses and potential environmental disasters due to unmonitored processes. Space agencies such as NASA and ESA continuously monitor solar activity to mitigate these risks. However, the unpredictability of solar storms means that we must remain vigilant. Investing in research and technology to better understand and predict these events is crucial. Education and awareness are also vital. The general public needs to be informed about the risks and the steps they can take to protect themselves. Emergency preparedness plans, similar to those for natural disasters like earthquakes and hurricanes, should include provisions for solar storms. In the end, while the sun is our source of life, it also has the potential to disrupt our existence profoundly. By understanding the risks and taking proactive measures, we can mitigate the impact of a solar superstorm and ensure that we are prepared for whatever the sun has in store for us in 2025 and beyond.